Hey everyone, Louis here. In the last video, I showed you how to install the JSGameLauncher on one of these cool little retro handheld devices. We did that so we can run games on it that were written using web technologies. Well, today I'm going to help you get started actually writing games. I put this guide up here on the JSGameLauncher GitHub page, and there's a link for it in the description of the video. The most important thing here, though, is that we're making games for the web. JSGameLauncher is just a compatibility layer. It allows us to write games that run on these devices, and these devices don't actually have a browser installed many times. Some of them are a bit underpowered, so something like Chrome or Firefox is a bit much. But just like when we're doing most modern web development, we want to make sure we have Node.js installed, and something like Cursor or VS Code. But use whatever text editor you like, and whatever operating system you like. For this demo, I'm on Linux using Cursor. And we're going to start out very basic. You don't need any real game development experience for this. Okay, let's get started. I'm going to scaffold the application with Vite because Vite's awesome. All we have to do is npm create vite at latest. And let's call this test game. We don't need a framework. We'll just go vanilla and we'll use JavaScript syntax. Going to go into the game folder, npm install. npm run dev, and we'll open that up. Okay, here we go. So we have a test page. Well, this is just a web page. It's not a game yet, so let's go in and start editing the code. Now, the code has got an index.html, some source. The public folder is where any public assets are for the game. But first off, the index.html, we don't really need a div. We need a canvas. In fact, the canvas is the only thing that the JSGameLauncher recognizes. So ID of game canvas 640/480. These devices here have a 640/480 resolution. So I'm going to go ahead and keep that just for performance reasons. You could use a different resolution if you want, maybe really high def, widescreen, and it'll scale. But we're going to start 640/480 here. And let's go into the source. And there's a bunch of source code in here that we don't need. So let's get rid of that. And instead, I'm going to paste in something here. So we're going to get our canvas element. We're going to get the context. Now, the context is the actual drawing API, where the canvas itself is just the element. Right, we're going to set the fill style to black and then fill a rectangle from the upper corner 0, 0 to the canvas width and height, and we'll see how that worked out. Yep, we have a black background canvas. All right, let's put an image in there. So this image is this Vite image from the public folder. And sure enough, it drew it. So even though this is a canvas, this looks like an image. I will show you that there is no image tags in here. That is an image actually drawn onto the canvas. Okay. Well, games require some animation, right? So if we think about some animation, let's say we want to start in the upper left corner, the X and Y. But we're gonna make a game loop here, a really simple game loop, so we don't really need a game engine or anything to go along with this. But I'm going to paste some stuff in here, and we'll just go through this code. So, all right. So this last time, that's just sort of a time tracking mechanism we have here. But the important functions for a typical game loop are our update, and so every update for this amount of elapsed time, and elapsed time is the number of milliseconds since it was called. Remember, in a game loop, we're going to update things, we're going to draw things, we're going to keep doing that over and over again. And elapsed time, if you're running at, say, a 60 frame rate screen, that's about 16 milliseconds. So we want some multiplier for our speed times the amount of elapsed time. And the reason we do it that way is because if you have a really slow computer, it should still take your, maybe your player to go across the screen the same amount of time as it would if you had a really fast computer. The player should still, start on one side, get to the other side. But on a fast computer, it'll be nice and smooth. On a slow computer, it'll be choppy, but it should still go the same amount of distance. And that's why we consider time on our update. And then we are going to draw again every time. And this time we're going to use the X and Y coordinates that were updated. In our game loop, this thing that just gets called over and over again, we'll do some math here to give us the amount of time that has passed on every update, do the draw, and then it uses this built-in request animation frame, which is basically the browser's API to say, here, I have a time slot for you to do some work and do some updates. And we're going to pass that the game loop. So we're doing this thing recursively. But in order to get it started, we'll get it started. Instead of drawing up here, when that image loads, we'll do the first one. We'll say request animation frame, the game loop to sort of kick this thing off. And if we get back here to the screen, there we go. It's going across. And it's a nice smooth animation. And what we did here is in our draw function, we kept doing the fill rect to sort of clear the screen. If we were to take that away, it would look more like that. So we cleared every time, right? Okay. So this is great. We have some animation going, but games require some user input. So how about instead of just updating based on time in our update function, we instead listen for keyboard events. So we get keyboard events with document add event listener key down. So if we press the arrow right, we're going to increase the X left, and then the Y coordinates with the up and down arrows. So by just putting that in there and not automatically updating, we should still be changing our X and Y. So our draw function should still work. And let's go to that. And sure enough, I'm using the keys, and we are moving this around. Okay. And that's great, but you might have noticed on this, this is the Anbernic RG40XXH. I've got some other ones as well. They usually don't have a keyboard on them. You have to use the gamepads. Well, luckily, the browsers have a gamepad API. It's a navigator.get gamepads. And the real key to using that is to have a controller. This is a pretty cheap one. This is a little knockoff Xbox controller. But they all sort of have the same thing. A standard gamepad mapping is 2 analog sticks, a D-pad, 4 buttons. Now they're always labeled differently. Nintendo and Microsoft and Sony all label these 4 buttons different, but they all have 4 buttons there. And a couple of shoulders and triggers. Now, if we want to test this out, we can go to a site I built, gamepad tester here, and this will kind of show you. So even though we've got things mapped, like my little display here says north, east, south, west. We've got these analog sticks. You could even click them. You've got this D-pad, and that's really nice that that we have these mappings. But all we're getting from the gamepad API is the button numbers, right, and whether they're pressed or not. So on our D-pad, we've got 12, 13, 14, 15 for up, down, left, right. So if we want to use that back in our game code, we can do this. We can update our update function. And so we call navigator.get gamepads, and it's going to give us back an array of gamepads. So if you have, let's say, 4 gamepads connected, you have 4 players on the same screen. That's how that works. So navigator.get gamepads gives us back an array. But it might actually have a bunch of nulls if you don't have a gamepad actually plugged in. And so here's our buttons, the up, down, left, right, and those will correspond to us changing the up, down, left, right here. So I'll save that and go back in to our little game demo, and sure enough, our controls on this D-pad are moving that around. So just from here, there's a lot we can do, right? We can do collision detection, more animations, more drawing, all of that, and build just on this. But before we do that, let's take what we've made so far and actually put it on the device. So if you followed the previous guide, the last video, you have the device set up and ready to go for this. I'm going to copy everything over the network here. And I've got a test game. I've got, this right here, so this is going to be different operating systems, right? On your file explorer and your network neighborhood might look different, but on Windows or a Mac. But when you have one of these devices connected to the Wi-Fi, you should be able to get to the folders on it. So we want the ROMs, the JS games, and we'll create a new folder called test game. Okay, and there's nothing in it yet. Now, before we copy everything, there's one last step in our code. Now, our test game, we're going to create a new file, and this file is going to seem a little weird. Testgame.jsg. Now, JSG is not a real file. It's just an empty file. But the game launcher on this thing is called Emulation Station, and it needs a way to identify that there's a game in that folder. So we just came up with this convention. JSG means JavaScript game. And there's no content in here, but that just signals to Emulation Station, hey, this folder means game, so put it in the menu. All right, and back over to our folders and our test game here. We don't need the node modules folder because that really just had all the stuff for vite. Our game didn't really have any dependencies in there. So we copy that over. And I go over here to user interface settings, and I on the user interface settings there's a game settings. It's up at the top, and I'm going to update the games list. And now with our updated games list, our test game is available. I just click launch. It takes a couple of seconds to launch. Well, most of the games on here take a little bit. So here we go. So what we made in code here translates to something that is able to work on the device itself. Now, we could go and keep building like this and have it so that we're coding directly onto that API, using that API for gamepads, which was this guy right here. But we don't really want to do the redundancy, right, of handling keyboards differently than gamepads. So in the JavaScript game launcher docs for making a game, I've got an example down here of using the simple JS game starter. So you might want to start with this one as opposed to starting from scratch. So this still isn't another game engine. You can use a game engine to do some of the same stuff I'm talking about right now. But I'm going to go ahead and copy that to the clipboard. I'm going to open a new tab here and git clone that as, let's go test game test game 2. Very creative. So go into test game 2, npm install, npm run dev. Open this back up, and very, very similar to our very simple demo. But what this did is it gave us both keyboard mappings. Oh, also a sound example, which is nice. Gamepad mappings. But what's different here is the code. There's an abstraction for test game 2 where the code is a little bit easier to reason about. So it has this utilities that have this get input for player 1. And if there is a gamepad, player 1 means the gamepad. And instead of, button 15, 12, there's D-pad, things like that. So just a simple utility to help out. Also, that image tag that we did earlier, where we had a little callback. This thing gives you a promise. If you're familiar with JavaScript promises, you could just do a load image, things like that. So if you want to start with this template, template that is described over here. You're welcome to do that or use whatever you'd like. That pretty much wraps this up. If you have any ideas on what to build on next, hit me up, say something in the comments. I'm thinking I might do something based on using AI with the little template scaffold thing, but let me know. Thanks.